Hello everyone, I want to present our team. We are Neira Gang team and we were working on the p300 speller dataset analysis. p300 speller dataset is a brain-computer interface that uses p300 EEG waves to help users select characters by focusing on a flash and stimuli. It helps people with severe motor disabilities. Previous study showed that raw column flashing perform better than imagery brain-computer interfaces. Offers 30 seconds per characters in comparison of 60 seconds in the motor imagery. And we were wondering, can we speed up the input more? On the slides, it's our dataset what we were working for 5 subjects. We performed the event-related potential analysis. And we decided to make adaptive averaging of stimuli to instead of fixing the number of repetition, 15 flashes, what was done before, we tried to decrease this amount. And we thought of a system that dynamically stops averaging when the confidence of the classifier reaches a threshold. In our case, it's 80%.
So we did some data exploration, figuring out that playing around with the windows or slightly shifting the epoch effects affects how many stimulus repetitions are needed. And so because most of the team had no prior experience, we decided to play around with the data at the processing stage and benchmark. So we did 3 pipelines. One is raw from 0 to 400 milliseconds. One is pre-processed, where we applied 0.1 to 30 hertz bandpass, 50 hertz nodes, and a baseline correction, and the same but for 200 to 400 millisecond window. And here you can see that the results that with completely raw epochs, basically we see that there are required many more flashes for the LDA, but by adding the standard preprocessing, we see that LDA's curve smooths and shifts up by 2 or 3% probably, and that TVLDA still requires less flashes. And narrowing down the window to the third graph, we see that the LDA gains another 235% and that the TVLDA hits a very good target. And we know that in real BCI, you'd stop flashing as soon as you're reliably confident. So what we did here is that we defined the certainty as twice the distance from the chance. And then here we do slide an averaging window over all test trials and average those certainties. If it exceeds 0.9 on 2 back-to-back windows, we stop. And with this, we saw that basically TVLDA required only 2, while LDA required doubled, that is 4, demonstrating a real-time speed up. And basically this is it. Thank you so much for watching that, and we're open to any questions.